Hello, my name is Dweeb, and today we're going to be doing our fourth video series lesson in this series, which is about arrays and lists. So let's first do a bit of a high-level analysis here. Python has four built-in data types, and what do we mean by this? Well, so far we've been talking about variable data types, singular variables with different data types, these being integers, strings, booleans, and char. Char being the less common in Python, but integer and string would be the most common, and boolean coming into play with conditional statements, like if statements or while loops, where a condition has to be true or false. But these are all singular variable data types. So what if we want to have a collection of data? That's often true, because let's say if I have a shopping list, right? And that word list is going to come to be a very important distinction later in this video, but let's say I have a shopping list. I don't want to have 10 slides or 10 pieces of paper to store each item I'm going to buy. I want to have one big piece of paper, one folded piece of paper full of all the things I want to buy, right? It's more efficient. And that's where these data types come into play. Lists, sets, tuples, and dictionaries. And for the context of this video, we're going to only focus on lists. The other ones will be detailed in future videos. But why are they important? The reason they're important is because not only can we store multiple values of data, but we can also streamline our code to access each element of data depending on what we need it to be. And we can also allow for randomization, which again we'll come to in a bit. So I was just talking about lists just now, and you're probably confused by why I'm now talking or going to talk about arrays. Well, let me explain. In Python, technically, these are called lists, not arrays. But in most other programming languages, we call them arrays. The reason I put lists as the data type in the previous slide is because in the context of Python, we call them lists, because that is the proper variable data structure type name, right? But in the context of general programming, they are arrays. So arrays are used to store multiple values in one single variable. So like I was talking about with the shopping list example, if my shopping list is called my shopping list, that can be my variable name, right? An array is a variable in the sense that it can store multiple values. Okay, it's not a variable that can store one value, it's a variable that can store multiple values, okay, in a list, right? So it can have any value variable name, right? It can be fruits, my favorite color, whatever, right? So let's say if I'm going to do that, then I can have many elements stored in one data type, which allows me to therefore streamline my code. I can use less lines of code to store more data. And they can hold therefore one more value at a time, like a list of items, as I mentioned earlier. So obviously we can tell therefore that the fruits example, the bottom example with banana, apple, and orange inside an array is much more efficient and streamlined than having fruit 1, fruit 2, and fruit 3. So that's really the key distinction between lists versus arrays. So the reason that we've been talking about lists in the context of Python is because to use an actual array, the proper array in Python, you have to input stuff, whereas lists are built into Python. And the distinction between arrays and lists in Python is so small because those input libraries you need to use, there's not much added benefit to it. So for the context of our programming, we're going to be talking about lists because they eventually function the same way as a conventional array in a different programming language. So lists and arrays are basically the same thing. They're both ordered. You can add and delete items after it's created, and the items don't need to be unique. The add and delete items is very important, and we're going to talk about functions to add and delete these items later in future times. But in lists, and this is a very important part that is not true for arrays, the elements can be of different data types. So you can combine strings, integers, and objects in the same list. But you can't do this with arrays. What that means is, if I have a shopping list, with a list, I can have apple, banana, pear, 5, 10, 15. 5, 10, 15, let's say, being how many apples, pears, and bananas I want to buy, right? But in a conventional array in Python, with the importing and stuff, I can't do that. I can only store apples, bananas, pears, and then for the 5, 10, 15, I probably have to create a new array, okay? So that's what's a really, really important benefit to using lists, and that's why it's kind of built into Python, because it's just easier to use. So getting values from arrays. So now we've been talking about, storing values in arrays, inputting values into arrays, essentially, right? We're storing values. But we want to get the values out and then work with them. So you can access the values by referring to an index number. The index number indicates where that particular value in the list is positioned within the list. And the interesting thing is, just like in Python where, normal values for indexes and whatnot look a little bit different. For example, for loops, I told you before that if I'm doing for I in range 1 to 11, it only outputs up to 10, because 11 is the upper bound, it's 1 greater than what you actually want it to be. So similarly, a little bit strangely, the index number actually starts from 0 instead of 1. So actually, fruits equals banana, apple, orange. The index number for the first element is 0, then 1, then 2. So just keep in mind that if you want to access, let's say, the fourth element in a list, then your index number would be 3, 4 minus 1. So, like I said, x is fruits 0. So the way we access it, therefore, is x equals fruits brackets 0, square brackets 0. So square brackets indicate where the position is. So the value inside the square brackets indicate what particular element in the array am I taking out or assigning to a particular variable. This is x and y. So now we've talked about, getting those values, but what if I want to input those values or change those values, more accurately speaking? Then what I'm doing essentially is I'm working with the array. Instead of using a separate variable to store the value for the array, which we can do, let's say if we want to take out apple, store a different variable, and then replace apple with something else, then what we would do is we'd do x equals fruits 1, which means x now is the value of apple, and then fruits 1 equals, let's say, melon. In this case, it says fruit 0. I'm just giving an interesting example. So this would do in this case is fruits bracket 0, it means it replaces the first element with banana to melon. Same happens for pear, in a different position within the list. So I previously talked a little bit about and briefly mentioned adding and changing values in a list, whereby in a list or array you can add and delete values. And to add values, use a method called append. Append, and this is a very common term in programming. So when someone says, I want to append my list, right, you're probably thinking that's some fancy term. It's very simple. Appending my list basically means I'm adding an element to my list, okay? And then what that means is I'm adding a value at the end of the list, usually. Now, there are ways to do it in different positions and whatnot. For the context of this, what it would do, it would have apple, banana, cherry as the first output values when you print this list, and then it would have orange, because it's adding it to the end, okay? And it's doing this list dot append. That's something that's key to know. It's an interesting method. You have to use a dot before it. That's something that happens for many Python methods. So adding values to arrays. So to insert list item a specified index, which is what I was talking about a little bit about earlier, whereby in the case of append function, the append method, I'm adding it to the end of the list. But what if I want to tell it to specifically go into a particular position? Then I use the insert method, where it inserts it into the list in a particular middle point. And I'm specifying that point. So that means that two parameters this. First parameter being the location of the index, where I'm inserting value. Second being the value I'm actually inserting. So this is exactly like how we have the functions, but you have different parameters and arguments. In this case, the parameters and arguments are 1 and orange. Okay. So looping through arrays. So we've all been now talking about, inserting values into arrays, deleting values from arrays. Well, not yet, but inserting values into arrays mainly, right? We're going to loop through an array and output all the values in an array, or so on and so forth. Then use a for-in loop, right? A for loop, okay, to loop through all the elements in an array. So for x in fruits, x being each element, that number counter variable, in fruits being the array list, right? We're printing x. That means basically what this loop does is for every single element in that fruits list, it just outputs it to the console. Looping for arrays. Right, so there's a distinction between looping for lists, looping for arrays here, and looping for arrays here, because you can also loop through the list items by referring to the index number. Okay? Here we're just doing it through all the elements, but we can also use a slightly more complicated method, and that is whereby we're saying you can loop through the list items by referring to a specific index number of those items in the list. So we have this list equals apple, banana, cherry. For I in range of len of this list, meaning that the range is the length of that list, we print that position value of the list and use the range and len functions to create a suitable iterable. Iterable being something that you can iterate through, which is exactly what you're doing in the context of a for loop, a count controller loop. So I accidentally misspoke earlier when I said we have talked about removing values. We haven't, but now we are going to. So to get rid of values in an array, there are two methods. One's a remove method and one's a pop method. So remove method removes the specified item. What that means is, in this case, let's say if I did this list is apple, banana, cherry, right? If I do this list dot remove, okay, again, all these methods have a dot system where it's the list name dot the method name, okay, dot remove in this case. Inside remove, we have inside the quotation marks, banana. So what I would do therefore is from the second position here, apple, banana, cherry, banana is in second position, so the index number will be 1, as I said earlier. The index number is 1 less than the actual position, right? This list dot remove banana means it removes the specified item, okay, of banana. The pop method removes the specified index. If you don't specify the index, the pop method removes the last item. So if it was this list dot pop and I didn't have the 1 inside, it would just remove cherry automatically. It would remove the last element in the list. I'm saying dot pop 1, it removes the item at the index of 1, which is also banana. So Python has a set of built-in methods that you can use on arrays, lists actually, because, well, we've been talking about lists, right? We've been using the list names, so on and so forth, because these are all list methods. They can be used in actual Python arrays with these actual complicated implementation methods, but usually we just use them for lists. And there are a lot, so try experimenting with these. I'm not going to read them out all to you because you can see on the slide, pause the video if you need to, but all of these methods, you have to add them by doing list name dot append, dot clear, dot copy, so on and so forth. And you have to have the brackets, because inside the brackets you might have to include parameter, maybe you don't. It depends on the context of the method. So let's code. Change the value from apple to kiwi in this fruits list. Okay, so we're talking about the changing function of DList, which I talked a little bit about earlier. If you forget, go back, rewind the video a bit, and I'll explain in that particular instance. Now the lemon, therefore, as the second part of this question, as a second item in the fruits list. Another problem for you guys, write Python function to sum all the items on the list. And this is where, to give a little bit of a hint, you use a count control loop. Use a for loop to iterate through the list and basically add it to a variable. Okay, so here's the answer. Okay, so in this case, I've used a function because we've talked about functions before, but I wanted to practice that. I want to ensure you guys knew that you can use a function here to kind of streamline it. You don't have to use a function necessarily, but I'd say it's the more effective and efficient method of combining this problem. So write a Python function now to get the largest number from the list. Again, similar method with a count control loop and a function. So what this is therefore doing, to explain this part of code, because it's a little bit more complicated than the previous question, we're taking the maximum value from the list at position 0, and for the number inside the list, the number variable inside the list, we're iterating through, and if the number is greater than the maximum, right, then the max becomes the number. So what that means is we're first taking the max value to be the first value in the list. And then we're iterating through and checking, okay, is the next value greater than this one? Okay, it is? Great, so then that's the max value. Great, then checking again. So first, the max value is 1. Then we're asking, is 2 greater than 1? Yep, it is. 2 becomes max. Then checking, is minus a greater than 2? Nope. Is 0 greater than 2? Nope. Okay, so then it's 2's maximum, return max, it returns the maximum value, which is 2 in this case. Now another question, right? A Python function takes 2 lists and returns true if they have at least one common member. And this is where you'd probably have to use a while loop and function. We can also use count control loop. I've used a count control loop in this instance, but I think if you really want to practice how to use while loops, you can also use that as the answer system. Okay, so here's the answer. So you have def common member, list 1, list 2, result is false. So we first set the result value to be false. And for an element in list 1 and for an element in list 2, you have a indented for loop. We have 2 for loops, nested for loops in this case. If the values of x and y are equal, then we set the result to be true, because we're looking at 2 lists and returning if they have at least one common member or number. Right? It doesn't have to be more than 1, it just has to be at least 1. If it is, then we make result from false to true. So it's literally false, because we don't know if there's actually commonality, and then we make true if x does equal y between both lists. Okay, so this is a challenging piece of code. Write a Python program to switch the position of every nth value with the n plus 1 element in a list. And for this, you'd have to do a little bit of coding regarding position values, using index values. Okay, and another difficult question here. Input a number, or parameter in this case, and find its highest prime factor. Okay, so pause the video whenever you want to, and now I'll show you the actual answer, because I kind of give you a hint there, but you didn't see it. Okay, so here's the answer. Now this is an interesting piece of code, because this is actually using other of libraries, right? Because I wanted to make this a little bit more complicated. This is from Iter Tools. Iter Tools is a common library to use this kind of stuff. Again, it is possible to use to do this code without these libraries, but I use those libraries to show that it is possible to use other libraries to solve this problem. So replace to copy this first element, and it returns the list as the longest value in those two elements, and then from there, it then uses the list of n to then try and find the prime factor. And now, I've kept a past question here from a competition, which is called the Canadian Computing Competition. You don't have to do this, but I put this question in because I found that these problems tend to be really useful to try to understand conceptually and to solve. And this is from the Canadian Computing Competition. It's from 2018. There's 2 challenges you can do, the junior and the senior. There's no age group. The junior is just the easier one, the senior is the harder one. This is the first problem in the question packet, and you can give this a shot. I think it's very much easier to solve using what we've done before. It is nowhere near as hard, trust me, to do than this difficult question. This difficult question is much harder. These are the kinds of questions that come up much later in that question packet, much later in that competition. So pause the video when you want to, and then we'll show you the list of answers. Okay, so here's the answer. So you can see it's a lot easier here. You just input 4 numbers, and then you're checking if which number is which, and then adding values accordingly, and then say ignore our answer depending on the values inside the list, right? Or more accurately, the values inside the sort of quote-unquote list, because we're not actually having a list here, but we have sort of a list of numbers of number 1, number 2, number 3, number 4. Now, this is a little bit of an inefficient piece of code. Now I look back, you can do this using arrays, but it would make the code longer, so it depends. The runtime would be quicker for this array-based code, but this is quicker to type out. That's why we do this way. And if you want some further practice of how to do these Python exercises, you can go to this link, which we'll also put in the description below. Okay, so now we're going to talk a bit about sets. Okay, so we've talked a little bit about lists in the past, so now let's talk a little bit about sets. Okay, so a set is a collection which is unordered and unindexed. So I was previously talking about lists and whatnot, lists and arrays. So let's talk about sets, because that's another data type that comes to be a very, very important use. And a set is a collection of data which is unordered. So what does that mean? Unordered means that you can't use an index value to get a certain value out. Okay, and these sets are written with curly brackets rather than square brackets we use for the arrays or lists. Okay? And you can't access items in the set by referring to an index or key because it's an unordered list. Okay? Right? You're storing the values in the set, but it has no particular order. Okay, but you can still loop through for set items using a for loop or ask the specified values present by using the keyword of in. Okay, you can still loop through and get values, but unlike in a list where you can use the position of an element in the list to then get values, here you can't. You just have to loop through the list and just get values in a random order. Okay, because these values inside the set, they don't have any specific index values or position values to indicate where they are. They're just there. Okay, so that's a brief introduction to sets. We'll talk about more in future lessons, but just for a little bit of a high-level overview, lists, you can have particular order. You can loop through based on the order of elements in the list. You can add and append values, delete values, so on and so forth, and there are other methods. Sets, the difference is that you can do many of those methods, but you also can't because of the fact that it's an unordered list. Okay, a list is an ordered list, an array is an ordered list. And that means that you can still loop through a set to get the output values, to get values from the list and output it to console, but you can't use the position values of the set because there aren't any. Thank you for watching. Please like and subscribe if you want to see more of our content. This is DList signing out.